Okay, short video here today about using a vehicle speed sensor input into a MS3X card on a Megasquirt 3 ECU. So we'll have a look at these circuits here on our left. We've got 4 circuits here that we can use. Data log in, table switch in, which is what I'm actually using at the test. Nitrous in and launch in. So you notice they're actually all the same circuits in effect. Nitrous in has got the removable pull-up, which I suggest you use if you're using it for a VSS, because it's a nice neat way to get a 12 volt pull up, and 12 volt is going to work better than 5 volts in this case. So you see you pull up 12 volts, you've got a low pass RC filter with your 10k and your capacitor to the ground there, and you've got your diode package there for protection. So that's there primarily to protect the input to the micro and stop it getting the 12 volts and blowing it up. So we'll see that doing its work in a minute. Also here you've got PT4 on the bottom right. So this is the one you want to use first. This will give you a higher frequency. I've tested this out to 2000 hertz, 2 kilohertz, and it was fine out to that far. I'm using it for my rear wheel speed sensor, which I need about 1100 hertz for. So we'll do some signal injection here. I'm using a Megasquirt 2204A, and I'm feeding in 50 to 650 hertz sweeping. You'll notice, look down on the bottom left there, when that hits 600 hertz, you'll see that VSS drop right now. So that's effectively, that's all you're going to get out of it. That's it cutting off, and it can't read anymore. So we'll have a look at why that's happening. This is effectively the output of my Hall effect sensor on my gear tooth sensor. So you notice it's a nearly 12 volt square wave. And now channel 2 is coming up. So this is after the filter. So you notice we don't have nice straight up and down lines. We've got the capacitor charging and bleeding down there. So you notice as the frequency goes up, the period goes down. And you'll notice that we're not getting to 0 volts anymore. Now, one thing to notice here is, look at the, and it becomes more apparent at the lower frequencies, but the rising edge is actually not too bad. It's the falling edge that seems to be limiting us. Look at that right there. Now, I think that's due to the 12 volt input. It's actually the Shockey's cutting it off at about 5.2 volts there. So we're effectively being limited by the falling edge. Here's just an example of what I'm using on my front wheel. So I've got 9 teeth on that wheel, and I'm using a Cherry gear tooth sensor or Hall effect sensor there. That'll give you a square wave output. It's using the pull up from that table switch circuit that we looked at earlier to give the voltage pull up. Here's the calculations you can use to figure out what you need. So we said, so those 4 we looked at first, you're going to get about 600 hertz out of those. So you can use those if this calculation comes out for you. So we'd go on metric. Max speed, I'm using 240 k's, is about as much as I went out of that car. Divided by the tyre circumference in meters. Make sure you get your decimal places right. Divided by 3600, which is the seconds in an hour, because you've used kilometres an hour. And that'll give you rotations per second. So then you need to time those out by how many teeth you've got in your sensor. So this will give you your effectively how many hertz you're feeding in. So if that's under 600 if that's a front wheel one, then you'll be good to use any of those. For a gearbox or a tail shaft, remember you need to multiply that by the diff ratio as well. So that is going to limit you there. So I've only got 8 teeth on my gearbox sensor, but with a 3:1 ratio, same tyre size, it's going to be around 1100 hertz. So I'm using PT4 for that one, just with a 5 volt pull up, and then I'm using table switch for my front wheel, and I think it's all going to work. Showing by this testing, it looks like it should be good. Initially, I looked at the circuit and thought it's got a negative 3 dB cut off on that filter of around 200 hertz. So I thought that was going to be the limiting factor, but after doing the testing, and that's why I decided to do this video, just to show what's going on. It should actually it should all come together and it should work. So I'll post some videos later when I actually get this car running, and we'll see how it goes with the traction control. But that's just some options of what you can use. If you do need more than 600 Hertz on both your inputs, obviously use PT4 first. For your second, you've got options there. You can use your main board inputs. So look on Tuner Studio for what inputs it gives you, and you can feed into any of those. And you just need an interface circuit, which effectively you could copy the PT4 circuit there. Or another option, which I was thinking of doing, was just to remove the capacitor on one of those other circuits on the 3X card, if you want to mangle that card. Yeah, just Google removing SMD components. You might need 2 soldering irons. Is probably the easiest way, but that will be another option. That'll kill that the filter, and you should be able to get a much higher frequency out of that. So that's another option. It's Megasquirt, it's your choice on what you do with it. But I hope this video is just to explain what's going on and help people out. Thanks a lot.